Today we're excited to introduce you to CurbAlert,
our smart cane project designed to empower independence through technology.
Before we show you how it works, let's talk about why we built it.
Imagine you're recovering from a surgery, or you're an older adult who needs a little extra help navigating indoors. You have a traditional support cane, but it can't tell you when you're about to walk into a wall or miss a staircase. You have a traditional white cane too, but that does not provide you with any support when walking. That's the gap that we want to fill.
We were especially inspired by an old family friend of mine who shared a problem she was facing. Because of her mobility and vision challenges, she often needed both a white cane to detect obstacles and a traditional 4-point cane for physical support. But using both at once left her with no free hands, making it hard to carry anything, open doors, or even catch herself safely if she stumbled. She had to choose between being able to detect hazards and having physical stability, and that choice shouldn't have to be made. Our goal is simple: empower independence through technology. We wanted to design a smart cane that guides, warns, and protects while still feeling natural and freeing to use.
We started off by setting some clear design goals. First, the cane had to detect walls, indoor obstacles like chairs, tables, and people, and also both ascending and descending stairs. It should only detect what's directly in the user's path and not objects way off to the side or insignificant objects. We chose the path here based off the width of a doorway. Second, it needs to react fast, providing feedback within 2 seconds of detecting an obstacle. Third, it must meet a weight requirement of 5 pounds so that can be accessible to anyone. Fourth, it needs to be compact, robust, and run for at least 2 hours without needing to recharge. And lastly, the feedback has to be non-visual. We really wanted to encourage confidence within our users, so we chose a haptic feedback as opposed to an auditory feedback, so our users would feel like they're not disrupting anyone around them or drawing attention to themselves.
At the bottom of our cane, you will see our force-sensitive resistors, which act as pressure pads that sense when the cane is fully pressed on the ground. This box houses our main computing components, which includes our Jetson Orin Nano, our power bank, which is 5 volts, 3 amps, as well as the supports for our camera, as well as our Intel RealSense LiDAR L515 camera. As you move up the cane, we have a QT Py microcontroller, which receives all of the feedback from the force-sensitive resistors, and it also sends feedback through serial to the haptic motor controller, which sends vibrations through the handle to give our feedback responses to the user.
Here's what CurbAlert can actually do. If it detects an object to the left and there's an unobscured path to the right, it buzzes to alert the user that they should turn right. If it detects an object on the left, it has a distinct buzz to suggest turning left and that there's an object. If it sees a wall that's closer to the user on the left than an object is, it alerts the user that there's a wall and they should turn right, and it does the same thing for if the wall is on the right. It also recognizes when there are upward stairs, warning the user to avoid this obstacle, and it detects downward stairs with a different haptic, signaling to avoid this area as well. Lastly, it will only detect objects when they are in the user's path. Here's a demo of CurbAlert in action. In this clip, the user is approaching a set of stairs and receiving distinct stairs feedback on the handle. Then they approach a wall on the right, so they're getting the haptic feedback to veer left. Then an object on the left and getting feedback to veer right. This is an example when CurbAlert is used at the top of a staircase. It will notify the user once there is an absence of ground, and it will give strong, distinct feedback to tell the user to veer away.
The beauty is, the user doesn't have to overthink it. The cane gives clear, immediate haptic feedback based on exactly what's ahead. In the same way that we subconsciously recognize our text alerts for different apps, our users will be able to recognize each vibration pattern that corresponds to each hazard.
Here's a high-level view of how our system works. So we get information about our surroundings using the RealSense L515 camera, which gives us both an RGB stream and a 3D LiDAR stream. This data is then processed on our microcontroller, the Jetson Orin Nano, where we run a customized object detection model that uses YOLO V8 and is optimized and fine-tuned by us. This model would then classify everything in view to determine whether it could be a hazardous obstacle, it's a wall, or it's a staircase or downward stairs. And this information is then used also with our 3D LiDAR information to determine the placement of the different objects and which is closest to the user and in its path, to then determine what the reaction should be and what action should be sent to the haptic vibration controller, which is then sent to the QT Py and then sent to the motor controller and gives the user feedback.
We performed extensive tests to verify the accuracy of our system. For object detection on varying distances, we got an accuracy of 92%, so 46 detections out of 50 varying objects. For object detection on steps, we got an accuracy of 98%, with the only failure in detection falling in elongated carpeted stairs. For object detection on walls, we got an accuracy of 94%, with the main inaccuracies falling on slanted walls with one slide being too close. For differentiation and classification between all of the obstacles, we got an accuracy of 88%, with the main inaccuracies falling for a person standing on the stairs. For the haptic response, we got an accuracy of 100%. For the latency, we got a time of 1.84 seconds from detection to haptic feedback. The weight measurement we got is 4.74 pounds, and the FSR accuracy we got was 96%, with the main inaccuracies falling in thick carpeted areas. So in conclusion, all of our tests passed.
At the heart of CurbAlert is a simple but powerful idea. Everyone deserves the confidence to move independently. Mobility isn't just about safety, it's about opportunity. When users feel more secure moving through indoor environments, it opens doors to better social and professional experiences. Attending a family gathering, navigating an unfamiliar office building, or simply shopping independently. All of these moments become easier and more empowering when assistive devices work with the user instead of getting in the way.
CurbAlert helps remove physical barriers so users can focus more on connecting with others, participating fully, and seizing new opportunities.
Our motto is empowering independence through technology. And through CurbAlert, we hope to inspire a future where assistive technology doesn't just help users survive, it helps them thrive.
Thank you for watching, and I hope you are as excited as we are about making the world a little safer, smarter, and more independent.